Before we talk about how we construct and use linear models in application problems, we need to think about how we understand the slope. And remember how we defined slope. We defined the slope to be change in y over change in x. How do we understand this in a real-world context? Say we had something like this. Suppose that x represents the number of fishermen, and y represents the number of fish they catch. Right, so let's say we're told in a story that Suppose in a story we're told that 12 fishermen will catch 28 fish, and 21 fishermen will catch 49 fish. This describes two ordered pairs. This describes the ordered pair xy equals 12, 28, and the pair xy equals 21, 49. If I drew a line through those points and calculated the change in y over the change in x, I would get, 49 minus 28 over 21 minus 12. That's going to be 21 ninths. Simplifying that, we get 7 thirds. How do we understand that 7 thirds? Well, in lowest terms then, the change in x is 3, and the change in y is 7. A change in x of 3 means 3 extra fishermen. And a change in y of 7 means 7 extra fish. So the way we understand this is, for every 3 extra fishermen, they'll catch 7 extra fish. There's another way we can understand this, though. This number 7 thirds, we can understand it as just 7 thirds. We can understand this also as saying 1 extra fisherman will catch 7 thirds of a fish on average. Why slip in that on average? Because actually in real life catching 7 thirds of a fish doesn't really make any sense. But that's what the model tells us is happening, so that must be taking an average or something. We can understand the slope then as representing a rate of change. We understand the slope specifically is representing the rate of change in y with respect to x. That is, how much will y increase when x increases by 1? Now, of course, in application problems, we're not going to want to always call our variables x and y. We're going to want to give our variables names that remind us what they represent. And we can't very well go around referring to just the x variable and the y variable. So we need a little bit more terminology. The x variable, the one that we imagine having increased by 1, is called the independent variable. In particular, that is the variable that ends up multiplied by the slope. And if we graph the equation, the independent variable goes on the horizontal axis. That is, the axis that's usually the x-axis. The other value then, the value that takes the place of y, is called the dependent variable. So the dependent variable is not multiplied by the slope. And if we graph, the dependent variable goes on the vertical axis, that is, the axis that's usually the y-axis. Now in some problems, the way that the information is given is going to tell us what the independent and the dependent variable are. In other problems, we'll get to pick, in which case we just have to pick and be consistent through the whole problem.